previous lessons, we have been talking about parallelograms and special parallelograms, but today we're going to step back and in lesson 6, we're going to take a look at a couple quadrilaterals. And I'm going to call them a couple special quadrilaterals. We're going to look at the properties of a kite and the properties of a trapezoid. So we're first going to start with a kite. By definition, it says that it is quadrilateral with exactly 2 pair of consecutive congruent sides. Consecutive meaning side by side. So I can see here these 2 tick marks. Those sides are consecutive. These 2 sides are consecutive. So what is true about our kite? Well, properties of a kite, it says if a quadrilateral is a kite, then its diagonals are perpendicular. So similar to the rhombus, my diagonals added in are going to meet at 90 degrees. And you'll notice here that I'm going to have 2 larger triangles. Those are going to end up being congruent, and we may prove that later on. Also, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. You can see here that not all 4 of my angles are congruent, but there is 1 pair of angles, and those are going to be the non-vertex angles. The non-vertex angles, I kind of think of that as the sides of my kite. Those angles there are going to end up congruent. So we know if this was roughly 95 degrees, this one would be 95 degrees. Now, it does not hold true for the other angles are not congruent. But what I will tell you happens is that when this diagonal is in place, it does bisect those angles. And so I know total this needs to add to 360, but these angles would be cut in half. So. Okay, they're going to ask us to take a look at finding some angle measures in example A, and sometimes there are more than one way to come up with your answer. In my kite ABCD, it tells me that the measure of angle DAB is 54 degrees. DAB would be this angle, what I'm going to say at the bottom. And CDF is 52 degrees. First one they're asking us to look at is finding the measure of angle BCD. BCD would be this top angle here at my kite, the whole angle. Well, again, there are different ways to look at this. One thing, though, I do know I have this 90-degree angle, so those right triangles might help me out along the way. And I also know set congruent sides. So the first time I looked at this question, I thought, well, if this is 90 and this is 52, I know here that this small angle would have to be 48 degrees. And because that bisects, I can simply double it. But the other way to look at it is this triangle, BCD, is going to be isosceles. And so if this angle is 52, this angle is going to have to be 52. And we could subtract from 180 to find that angle. Either way, angle BCD is going to come out as 76 degrees. My angle ABC over here at the side, it's not 52 because I need the entire angle. Well, again, there may be different ways that you could go about solving it. One way is I know my entire kite needs to add to 360, and so I may consider taking 360 minus 54 minus 76, and then the quantity that I would be left over with would be angle B and angle D. I would simply divide that by 2 because they are congruent. I could also look at finding this angle here, 90 degrees. This angle would be half of 54, and I could solve for the angle and add it to 52. In the end, we would find out that that angle comes out to 115 degrees. degrees. Lastly, angle FDA. Well, if this angle is 115 degrees, this angle is 115 degrees. And angle FDA is this small part in there. We're just going to take 115 and subtract off our 52, and we would be left with 63 degrees. So as I said, sometimes there are more than one way to go about finding your angle measure, more than one strategy. In example B, we're going to be taking a look at finding some segment measures. They're wanting me to find the measure of KL. Well, I see KL, top to bottom is what I would say. I know my diagonals meet at 90 degrees, and so I have some right triangles. Well, in a kite, because of some congruent triangles, up here they're telling me that JM is 30. Well, I'm going to know that that diagonal is also split at its midpoint. And so I can be confident that these each measure 15 centimeters. Looks like I'm going to break this problem up. I'm going to look to solve for A first and then to solve for B. With my right triangle here, I can simply say that A squared plus 15 squared is going to equal 18 squared. And I could set up a second equation similar to that to solve for B. My right triangle here would allow me to say, well, 15 squared plus B squared is going to equal 27 squared. And we would solve each of those. Now solving here, we're going to get that A squared is 99. I did go ahead and work with my decimals. So I found out that A was about 9.95. Over here, B squared comes out to 504. So B was about 22.45. And in the end, I know that my length of KL, I can simply add those two together. Right? KL, 9.95 plus 22.45. And so we find out that it is about 32.4 centimeters. Now you'll notice a lot of times in class I'll tell you that you only need to round to the 10th. But because I knew I was going to use these numbers in another calculation, I actually rounded to the 100th just so that it was a little bit more accurate. Now we're going to spend some time taking a look at a trapezoid. And by definition, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Those parallel sides over here on my diagram, you can see the parallel sides are called the bases and the other sides are called the legs. Now, in the event where your two legs are the same, you're going to end up with an isosceles trapezoid. So an isosceles trapezoid is a trapezoid where the legs are congruent. And a lot of times that is the kind of trapezoid that you'll see on a poster, or the one that you learned back in middle school and grade school. So for my trapezoid, it has a pair of parallel bases, and I know my angles have to add up to 360 total. But other than that, I don't have a whole lot of properties that are true. You might see we have some same side interior angles. So I know here that my angle A and B, they would have to add up to 180 degrees. Same is true for C and D. But the following properties that we're going to talk about are true for an isosceles trapezoid. Okay, so when my two legs of my trapezoid are congruent, these properties hold true. If a trapezoid is isosceles, then each pair of base angles are congruent. Where are the base angles? Well, angle F and angle J is a pair of base angles. So if this would be 120 degrees, this would be 120 degrees. Likewise, the other pair, G, if this was 60 degrees, H would be 60 degrees. If a trapezoid has one pair of congruent base angles, then you can determine that it is isosceles. And finally, if a trapezoid is isosceles, if and only if its diagonals are congruent. So in my picture here, I can see if I have an isosceles trapezoid, then RT is going to be congruent to QS. Okay, in example C, we're going to take a look at solving for some measures. The first one, they're asking me to solve for angle A and angle C. Well, in this trapezoid here, my parallel sides, AD and BC, and so do I know what angle A to be 143? No, because it's not isosceles. But these two would end up being same side interior. And so A is going to be the supplement of 104. Likewise true for C. These are same side interior, and so that would be 37 degrees. Taking a look at the second picture, I'm going to go ahead and tell you that this is an isosceles trapezoid. And so if we were looking for our length of OP, well, OP here would have to be congruent to NM. It's going to have to be 11 feet. And CO, well, in an isosceles trapezoid, my diagonals are congruent, and it also happens that they cut it proportionally. And so if NC is 8, OC is also going to be 8. And then my total NP, 14 plus 8, a total length of 22, NP is going to have to be the same. In example D, they're asking us to find the value of A so that PQRS is isosceles. Well, when I look at this and I see my parallel lines, if this were to be an isosceles trapezoid, these would be my congruent legs, which would mean that angle P would have to be congruent to angle S. My base angles would be congruent. Likewise, angle Q would have to be congruent to angle R. Now, I know that I can now take my A squared plus 27 and set that equal to 2A squared minus 54. And we are going to look to solve for our value for A. Now, if I add 54 to both sides, subtract A squared from both sides, we find out that 81 is equal to A squared. And so what would we find for our value for A? Well, we would take the square root of both sides and find out that A is the square root of 81. Now we know that's a perfect square, but what I want you to remind you of is technically there would be two solutions here. A would be plus or minus 9, positive or negative, and both of them would work because even when I put in a negative 9 here, when I square it becomes positive. So technically on this type of question, there are two solutions. Okay, one last thing about our trapezoid is that a trapezoid can have a midsegment. And just like with our triangle, a midsegment is a segment that connects the midpoints. So we are going to connect the midpoints of our legs here. X is a midpoint and Y is a midpoint. And I can see that by the tick marks. Well, there's a couple properties that are true about your midsegment. First of all, your midsegment is parallel to the bases. All three of these lines parallel. The length of the midsegment is 1/2 of the sum of the lengths of the bases. Now, that can be a little bit difficult to understand in words, but really the midsegment is the average of the bases. It's right in the middle. And so if this were a unit of 8 inches or length, and this was a length of 10 inches, we know that my midsegment would have to be a length of 9, right in the middle. Or if I needed to solve for that, let's say I'm going to call this my xy solving, I would have 8 plus 10 and divide by 2. So as I take a look in example D, they're going to ask me to do some solving for our midsegments. Example D, they want me to solve for EF. Well, EF is simply the average of my bases, 8 plus 13.5, and divide by 2. Over here, though, in the second one, you'll notice that I'm solving for EH, and this is a base. My midsegment is 16.5, so I'm going to set this up just a little bit differently here. I'm going to call EH, I'm going to put a variable x there. So here, my 16.5 is my answer. That's what we got when we took our bases, x and 25, and we averaged them together. Okay. Now some of you might be able to solve this a little bit more mentally to know what to do, but if I needed to solve for x here, I want to remind you that we'd start by multiplying by 2 on both sides, because we'd want to eliminate our fraction. So we would end up finding 33 is equal to x plus 25, or subtract, and we would find out that 8 is equal to x. What does that mean? Well, my segment EH would have a length of 8. Okay, if you have further questions on this, please stop in and see me.